You've seen both of these two things before, right? In the last couple days, you know exactly what they are. What's this one? Square root. What's this one? Cube root. Okay? You've seen these before because I showed you things like this in our Exponent Foldable. I don't know if you remember us talking about this, but this is my Exponent Foldable. This is what we did when we talked about it. So I'm bringing us back to the Exponent Foldable because I want you to see what we did before. In our our power of a product page, we talked about anytime I raise something to a power, it's every single thing inside that parentheses raised to that power. We said 16 to the 1/2. We said 5 to the 5th to the 1/2, and b to the 1/2. From when we went here to here, what did we do? 16 to the 1/2 is the same as what? The square root. Because on the top page, the very last page of our foldable, we also wrote this. A to a fractional power or a rational power. The numerator of that fraction is the power. The denominator of that fraction is the root. So if I have something to the 1/2 power, the top is the power, so 16 to the 1st power. A 2 on the bottom means a square root. So the square root of 16 would be 4. Does that make sense? So then how are these two things related? They mean the same thing. How are these two things related? They mean the same thing. Okay? So what we've been discussing the last couple days is if I say to you x plus 1 equals 7, how do you solve that equation? How do you undo a square root? If I square both sides, here and here, I have x plus 1 equals 49, and I subtract 1 from both sides to solve for x. So x equals 48. I check my work by substituting my answer in. 48 plus 1 is 49. The square root of 49 is 7. 7 equals 7. So I know that that's the correct answer. But the thing is if I start here and my problem looks like this is the same problem. You have to think about it a little differently, only because a lot of you see this visual clue right here, and you know, oh, that's square root, I got to undo the square root by squaring it. Okay? The visual clue that you see over here is this fraction. Well, how do I undo a fraction? Well, according to our Exponent Foldable, if I raise a power to a power, I multiply, right? Well, I need this exponent right here to be a 1. And the way that I do that is I'm going to raise both sides, right, because I always have to do it to both sides, to the reciprocal of this power. What's the reciprocal of 1/2? 2 over 1. Why would I choose the reciprocal? When I multiply them, I end up with 2 over 2, and what does 2 over 2 simplify to be? 1. And that's what I need as my exponent on this left-hand side in order to be able to solve for x, don't I? So if I raise this side to the 2 over 1 power, I also have to raise this side to the 2 over 1 power. Now, do I actually have to put 2 over 1? Because 2 over 1 is just the same as 2, right? But some of you visually need to see the 2 over 1 so you know that you're doing the right thing, and I'll show you in a second why sometimes it is important. Okay? So on the left-hand side, just like before, we end up with x plus 1, and on the right-hand side, we end up with 49. To solve for x, oh my goodness. To solve for x, we subtract 1 from both sides to get x equals 48. Again, I plug in my answer to check and make sure it's correct. 48 plus 1 is 49. 49 to the 1/2 power. Knowing now that the power is 1, the root is 2, you know that means the square root. Square root of 49 is 7, and 7 equals 7. So you do know that that is the correct answer. Okay? Everybody understand that? I need to get a little bit more basic for just a second. Okay? Are you okay with that? So if I have a question like this, x to the 2/3 power equals 9. Well, this one's a little different than this one that we just did, right? Because that's 1/2, so that's just square root, no big deal, right? Well, this has an exponent, a rational exponent, that has something besides 1 here and something besides 1 here. That's not a problem, it's just something we have to think about, right? What am I going to raise both sides to when it's time to get rid of this exponent? Because 3/2, because that's its reciprocal, right? So 3/2 here, 3/2 here. Okay? Now, we can absolutely do this without a calculator. You can do it in your calculator. I'm going to prove to you that we don't have to have our calculator. First of all, on this side, I get 6/6, which is 1, so that simplifies to just x, right? Do you want to say 9 to the 3rd power and then take the square root of that? Can we say the square root of 9? What is the square root of 9? 3 to the 3rd power? 27. That's a whole lot easier, isn't it? Okay? But I'll tell you right now, that's not the only answer. Who put this root into the problem? We did, right? So if I take the square root of 9, what do I actually get? Plus or minus 3. So what is 3 to the 3rd power? 27, right? What is negative 3 to the 3rd power? Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. So you have to be careful about that. Okay? Anytime we put this root sign into the problem, because that's what happens, even though it's not a physical root sign, we're the one that's taking an even root, a square root in this case. We have to take into account both the positive and the negative of the situation. Does that make sense? Guys, I could do a whole bunch of more examples for you that look exactly the same as these, with numbers in the front, or numbers at the end outside, numbers at the front where we'd have to divide both sides first, numbers at the end where we'd have to add or subtract both sides first. You already know how to do that. What you don't know how to do is, or what you haven't known how to do before, is when it looks like this. But if you'll think about the fact that it's all the same kind of thing, you know exactly how to do these. We're just putting together things that I taught you some days, things that I taught you another day. We're putting it together as one day. Does that make sense? I will tell you this. I don't want you to be fooled or tricked. We're not going to do this whole problem. Well, I suppose we could. We might as well since we're here. What do I do first? Oh, you don't want to raise it to 4/3 first? No, we don't, right? We'd have to do the whole side to that, and I can't raise 2 to the 4/3 and get a nice number, can I? I want to divide by 2 first. I want to isolate my x first. X to the 3/4 power equals what? 4. How do I solve for x? Raise it to the 4/3 power. Now, you're allowed to do the power first and then the root. What do I always do? Root and then the power, just because it starts off with smaller numbers, right? Do you know the 3rd root or the cube root of 4? Neither do I. So how would I go about getting an answer here? So I have 2 options, okay? And really my options depend on my answers, right? You have the answer choices usually to choose from in your online textbook. If this was on a quiz or test, I would make sure in the instructions you knew exactly what I wanted so there was no confusion. Okay? But I have 2 choices. My first choice is this. Isn't that an answer? My second choice is this. 4 raised to the 4/3 power. How would you think I would tell you that I want the actual decimal? I would usually say round to the 100th, round to the 1000th, round to the something, right? I would say solve and round to the appropriate decimal place, right? If I didn't give you any instructions, which one of these is more correct? Yeah, it is, right? Because this one's a rounded number, this one's the actual number. But which one of these would I take if I wasn't, for whatever reason, clear in the instructions? I would take both, for sure. Okay? Do you have any questions on solving with rational exponents? Okay, well, that's a good question. What do I mean by rational exponents? What does it mean to be a rational number? A fraction, right? A ratio, a rational number. So do you see why this is called solving equations with radicals and why these are called solving equations with rational exponents? Yeah. Do you have any questions about that? If you have a question, what should you do? Ask. Okay? You have the rest of the period to work on this assignment. Ask questions if you need to. It's a great time for board points.